again, to everyone in the room, we'll be using Slido for audience questions, so you should join this link on your phone or your laptop or whatever you're using so that you can ask questions or use the QR code. So I'll give you a minute to do that. Okay, is everybody in? Okay, I think everybody's in.
Thank you for moderating.
Cool. Am I in the frame?
No, okay.
I feel like if I move forward like 6 inches, I might be in the frame.
Great. So, hi everyone. Great to see you all. I am very glad to be back. So I was here as an undergrad over 10 years ago. I was 18C, I lived in Baker, and now I'm an assistant professor at Cornell in the Department of Information Science. And today I'll be talking a bit about this particular set of research, but also more broadly about kind of an additional perspective to take when hacking. So one big question that kind of is kind of indicative of the type of research that I do is this. So I'm really interested in making sure that we can figure out how to best make decisions that can then reduce inequality in society. And so broadly, the decision-making aspect is stuff that I use computational tools to solve, so things like machine learning or causal inference. And in terms of reducing inequality, I'm thinking about lots of societal biases. Sometimes these are in online applications, sometimes these are in public health, for example. But broadly, what I work on, you can think of it as basically hacking for social good, right? So broadly using some tech stuff to think about some society stuff. And so a lot of my work ends up kind of at this intersection of thinking about tech and fairness. And what is often the case is that when you're doing hackathon projects, you end up thinking mostly just about the tech side of stuff. And I'm here to argue that actually there's a lot more you can do that involves this kind of fairness arc. Right, and so with that, I'm going to give one example. This is a PNAS paper done in conjunction with a fantastic and interdisciplinary group of people. So in addition to mathematicians, we also have computer scientists and linguists who work on this. And I really encourage you to also think about interdisciplinarity when you're thinking about groups that you're hacking with and that sort of thing. So with that, what I'm talking about today is on fairness in automated speech recognition, which I'll call ASRs. So what are ASRs? These are things that you might often see in your friends' homes, things like on your phones. You talk to Siri, you talk to Alexa, you ask them to do kind of basic things like maybe pull up a recipe or set a timer, right? But there are actually a lot more important and pressing issues that ASRs are used for. So there are applications, for example, especially for folks with disabilities. So if they can't use their hands to type, or if they have other impairments, they might actually really need to use ASRs, so it's really important to get ASRs correct for them. Right? These are now in cars, and you can imagine car safety is a huge issue as well. Doctors use ASRs to take patient notes, and so you can imagine that if you're mistranscribing what the doctor says, and the patient notes are incorrect, then you end up misdiagnosing a patient or mistreating a patient based on some of these tech-based issues. And this is also an issue in criminal justice, right? So we have court transcription services that previously came in the form of humans who are typing in shorthand everything that people are saying in the courtroom, and this is now increasingly so kind of an automated process where, again, this is the stuff that's being used to decide if someone goes to jail or not, right? And so it's really important to actually get everything correct when you're transcribing what people are saying. And so broadly, the take here is that there are all these really high-stakes applications of ASRs, and so if the ASR technology itself isn't fair, then you might have these really bad downstream impacts, right? So if you're disproportionately mistranscribing Black defendants in court, for example, you're going to be disproportionately making incorrect personal decisions based on those ASR transcripts, right? So this is a really important problem to get right. So what do we do? In this particular paper, we audited 5 different big tech companies. Hopefully you can puzzle out which logos these are. And broadly, the idea is that all of them have different speech-to-text systems, right? So we want to be able to see how they perform on different demographics, right? So for example, on white English speakers, white American English speakers versus Black American English speakers. And so this is actually something that isn't totally out of the blue, so a lot of similar kind of audit study type of work has been done. So you may have seen this work called Gender Shades by Koenecke and Koenecke, which was done at MIT. And they did a very similar audit, but instead of looking at ASR technology, they were looking at facial recognition tech, right? So on a suite of different big tech products, they're saying, oh, do these classification things actually work? And it turns out that they really don't work, especially for individuals with darker female faces, right? So can we do something similar to this in the land of speech to text? And the answer is that we can. So we pull some audio data from a variety of sociolinguistic interviews. This is when effectively you have a linguist who asks a standard slate of questions like, what games did you play when you grew up? Or, what did your parents do for a living? And then you get this naturalistic dialogue and response, and that naturalistic dialogue is most similar to how people actually interact with things like Alexa or Siri. And so that's what we want to get out of these data sets that have speech. Pointedly, these data sets also have human-generated ground truth transcripts. So what does that mean? It means we have the audio speech, so like a WAV file or MP3 file, and also what they're actually saying, right? So someone has actually verified that, in fact, these are the words that they are saying. And the main thing to take care of is making sure that we're not testing on the trained data, right? So if you've taken ML classes, you know this is a bad thing. The idea here is we want to make sure that when we're testing to see how good or bad these different commercial speech-to-text API systems are, we need to make sure we're not just testing them on the data that was used to train those products, because if they've already ingested those products in their models, they're going to get 100% accuracy on everything, right? So we need to make sure this is private data, and in fact it is, so that's how we proceed with our study. So we do some audio processing. We just make sure that they're kind of reasonably segmented snippets at conversational pauses, that sort of thing. And we're also matching on age, gender, and duration to make sure that snippets are relatively similar. So we have an apples-to-apples comparison between race. So for example, we have about 2,000 audio snippets of Black Americans speaking that are matched apples-to-apples to about 2,000 white American English speakers who are also similar age, similar gender, that sort of thing. So we feed them all into these black boxes of ASRs, and we get transcriptions for each of these ASR systems, for each of our Black speaker snippets and our white speaker snippets. And this leads to the question of, well, how do we know if these are any good, right? So these are just transcriptions that come out of your speech-to-text systems. And we know our ground truth before, right? So that was a stipulation. We had our human-generated ground truth. We think this is actually the correct transcription. So how do we actually know if these things are any good? And the answer is we use something called the word error rate. If you've taken a CS class and heard about edit distances, this is the exact same thing. This is just what linguists call it. And the idea is you want to count up the number of differences between the ground truth and transcriptions, and take that, divide it by the number of total words. So to go from what a great presentation to that is a presentation, you have to substitute what delete is and insert great. And so that's 3 changes out of 4 words in the ground truth, which gives you about 75% word error rate. So this leads to the question of, is this actually a good word error rate? Is this a bad word error rate? Who knows? So one thing I'll emphasize, error rate is bad. So high word error rate is really bad. Low word error rate is good, right? So 75%, pretty high. For context, if you had, say, someone messing up a transcription of every other word, so every other word is incorrect, you're going to end up with a 50% word error rate, and that's already pretty unintelligible, right? So this is super unintelligible. We already know that we're basically getting 3/4 of the words wrong. And this is what we find overall. This is kind of the headline that all of the media publishes on about this paper, which is that Black speakers, especially Black men, have a way worse error rate, very close to this 50% line of unintelligible transcriptions, relative to white speakers who have close to a 10 to 20% word error rate. That being said, these are numbers, like unclear what that means, right? So let's listen to a few examples. So this is a particular snippet for a white man speaking. This snippet happens to have a word error rate of about 0.2, so that's reflective of similar to the overall average of 20%. And you can see the red markings are where the speech-to-text system got the transcription incorrect. So I'll play this one for you.
Well, when I was really young, I had a book of basketball statistics, and I would spend a lot of time reading them. for some reason, I forget why now, but Jason Kidd ended up being my favorite player.
All right, so that's sample number one. Did anyone think that was particularly hard to understand? Seeing lots of head shakes. Okay, so now let's listen to another snippet. This one's spoken by a Black woman, and you can already see the word error rate is significantly worse. It's up to 0.3 from 0.2. You can see there are a lot more red markings, so a lot more places where the transcriber messed up. So now let's listen to this one. I want you to keep in mind, do you think this was significantly harder for you as a human to understand and transcribe relative to the previous one?
And she had these little like snow cone things. I don't even know what it was. There's not like the snow cones up here, like, I don't know how to explain. But, you know, a bag of candy for a quarter. Like a full bag of candy for a quarter.
Okay, so who thought this was much harder to transcribe than the other one? Okay, so one hand out of a sea of people. Broadly, this is one of the big issues here, right? Is that for humans, we could do much better than the machines can do. So what's going on here? One other thing I'll note is that we talked about how we were auditing 5 different companies, right? And all of these companies have the same issue across the board. So we're seeing about doubled word error rates, so twice as bad transcriptions for Black speakers relative to white speakers. So this kind of leads us to 2 different research questions. And so this chart is like the main thing that the media reports on, right? But actually, if you go into the paper and you think about the research that I and my team do, there are kind of 2 almost more interesting, more pertinent research questions that we focus on. So the first question is, how do we actually know that this is race-based and not something else? We need to really justify that, in fact, this is a claim that we're making. And the second question that I'll talk about is going to be, how do you actually fix this in the underlying machine learning technology? So how do we know it's race? This is a picture of the geographic variation, and the coloring isn't quite showing up on the screen, but these 3 locations are where our Black speakers are coming from in our linguistic interviews, and these 2 are where our white speakers are coming from. And so you might notice there's something funky going on in Rochester, right? So like, we have Black speakers in Rochester. They actually have really low word error rates that are comparable to all of our white speakers. So what if this actually has nothing to do with race? Like, clearly our samples from Rochester are outliers, so what's going on here? So another thing to kind of deep dive into is how people are speaking specifically. And so something like 80 to 90% of African Americans in the US speak some degree of African American vernacular English. So what exactly does that mean? It's a particular set of linguistic features that are generally indicative of this dialect or variety of English. And so what we can do is count the number of linguistic features that actually occur that are linked to kind of classically linguistically how we would define AV. So this includes things like the 0 copula. So the copula in the sentence "they are gone" would be the word are, A-R-E. So if you remove it, that's called the 0 copula. That would be a grammatical example of AV. There are also phonological examples. So final consonant cluster reduction means that you're not pronouncing the final D in band. So it's going to sound more like the word ban. And so if we count up all the times that this occurs in a sample of these things, we can understand a bit better about what's going on with these different ASR systems. So here's an example, really tiny word error rates, a really high accuracy, right? Very few red markings here. The ASR did nearly perfectly. The only place where there is a very strong AV feature, AV linguistic feature, is the, which is going to be a syllable initial fricative stopping, which just means that the TH is going to sound like a D, so it'll be a bit more like D instead of V. So I'm going to play this for you so you can hear what it sounds like.
Grow older, we get darker. So I was extremely light when I was a child and very skinny. And so I was like an outcast because I was made fun of because I was the white girl at the school.
All right. So hopefully you see where I'm going with this. Many more red markings, also many more blue markings, right? So not only do the ASR technologies do much worse, so the word error rate here is over 0.5, so more than half of the words are getting transcribed incorrectly. Also, a ton of the words are indicative of AV linguistic features. So I'll play this one so you can hear it.
Well, in 7th grade, she gave me the nickname Snake, because she said I was sneaky, you know. I'd be sitting one place and she turned around, I'm sitting someplace else.
All right. And so if you put these 2 thoughts together, what we're showing here is basically the share of words in a transcription that have some feature of AV, grammatical or phonological. And on the other side is word error rate, and again, high is bad, low is good. And so you see there's some positive correlation here, right? So the more AV speakers you speak with, the worse the ASR technology does on your transcriptions. But let's link this back to the idea before where we had this weird situation going on in Rochester, right? So all of our Black speakers in Rochester were doing really well, had really low word error rates. This is the exact same plot, just with colors now. And so it turns out that all of our speakers in Rochester are clustering down around here. So basically, none of them are speaking AV, is the main difference here. Whereas our speakers in DC and Princeville are speaking with much higher rates of AV vernacular English. We see that just not happening in Rochester, which makes sense because people just speak differently, right? And it just so happens that our set of people in Rochester are Black and are not speaking in African American vernacular English. So next, the thought is, well, not only are these racial disparities, we're specifically linking them to a racial linguistic disparity, right? So it's not just a black and white issue. The issue is that ASRs specifically do not perform well on speakers of African American vernacular English, right? So we can specify the problem a bit more. And the way to think about this, underlying what an ASR is the fact that speech-to-text models tend to comprise of two different machine learning methods that basically stack together. So one thing is language models. I used to have to explain a lot more about this. Now I can just say, this is ChatGPT, roughly, right? So it's the thing that describes what you're saying. So the specific words, it takes some sound and guesses which words make the most sense to come in the next sentence order. The other thing is acoustic models, and that's the thing that translates your sound waves into those phones that you can then fit into the language model. So you have these two parts that are working together, and what we do in the paper that I'm not going to go over today in the interest of time is figuring out which of these particular components is actually the reason that we're seeing these disparities in African American vernacular English. Broadly, we can text for the specific lexicon, so basically are speakers of AV and non-AV just using different vocabulary, and is that the reason that we see these differences? We can test on grammar as well, and we test on phonology. Short answer is, we found that acoustic models were the huge driver of the differences. And so overall, what our paper found was that, first of all 5 of the technologies that we studied had these massive biases specifically for African American vernacular English speakers, nearly doubling those transcription error rates. And in particular, a lot of these issues are traced to the acoustic model, right? And so that means that ASR technology just isn't there yet, specifically in the underlying machine learning modeling that have to do with syllable accenting, vowel duration, that sort of stuff. And so this kind of leads me to the question of I talked to you about my research, what do you do now with this? And so a lot of my work actually talks about what do you do next? How do you engage with the community to actually solve this problem, right? So in order to try and make the world a slightly better place, we have a few calls to action, right? So for example, working with different tech companies to encourage them to collect more diverse training data, because a lot of the issue is that the training data fundamentally is majority a specific homogeneous set of people, set of speakers. And this isn't just something that would help African American vernacular English speech. This includes people, for example, with speech impediments or non-native English speakers. All of these demographics are currently underperforming in ASR systems, and so this is a place where it's a relatively low lift for companies to invest in the data and then make better products. There is also, the fact that this isn't just a data problem, it's also a people problem, right? So people in this entire pipeline, from product managers and data scientists down to software engineers, if none of them are thinking about these sorts of issues, they're just going to be perpetuated. You're not going to catch these biases until they're actually in product. And so that's bad, so we want to catch them ahead of time. We want to make sure that people are actually reporting their results publicly, right? So this whole research was kind of a pain because we had to go and find the data set and do it ourselves. It would be great if the actual companies themselves would do this and publicly report how much better they're doing than their competitors. That would be a really strong indicator of, their product is better than others. And lastly, we want to learn from especially legislative progress being made in other domains. So going back to our computer vision example, right, so gender shades found that facial recognition tech was much worse on different demographics, especially darker skinned demographics and women. And so as a result, they actually made a lot of concrete change. So they actually went in front of the US government, talked to them about reform. This research coincided a bit with the Black Lives Matter movement, and as a result of that, specifically their research resulted in IBM, Amazon, and Microsoft no longer selling their facial recognition tech to police forces because of the bias. right? So a lot of huge changes being made thanks to that bias auditing done in the computer vision space. So what about with speech technology? So I'm going to tell you a horror story, which is that a lot of incarcerated people's phone calls are currently being surveilled, right? So they're being wiretapped, and this data is actually being recorded. And what one particular company is doing, and something that is being a service that's being paid for by many, many prisons in the US, is this particular product. And so how it works is that they listen to the phone call, they get a transcription of it using the Amazon speech-to-text system. I know this specifically because I read their whole documentation. So they use Amazon, they get the transcription, they take a histogram of all the words that are being transcribed, and if any kind of list of like a set of words, so things like gun or suicide or murder or things like that, are said, then they flag it, and then decisions are made. So for example, someone might be sent to solitary confinement as a result of something that they said on the phone. Right, so this is a huge issue. But something that I want to call out specifically is that this company claims that there's no implicit bias, no racial profiling. It just analyzes and reviews call content. I think this is a really common mistake that people can make because they don't consider the fact that something that's happening somewhere between these steps is hugely biased, and that bias is baked into the technology, right? So horror story to keep in mind when people tell you, oh, I'm using this technology, and because I'm not including anything about the race data of the prisoner or anything, like it doesn't matter. It does matter because the tech implicitly has this bias. So another potential horror story has to do with court reporting, right? So as I mentioned at the beginning, this is really important because if you transcribe not as not or things like that, you're totally inverting the meaning, and this could totally invert some claim that a lawyer is trying to make in court. This is all moving digital, right? So we now have increasingly ASR court transcribers instead of or in addition to humans. But then we also have this question of like, are humans actually any better than AI? Because you also have biased humans, right? So this person asking, assuming that someone asked for a lawyer dog, which does not exist, and then they did not, in fact, give them a lawyer because of this sort of human bias. And so hopefully I've convinced you with this talk that in fact ASRs are biased and a lot more work needs to be done, not just on the race bias aspect, but also just being good enough at understanding this like lawyer-y court-specific jargon. But humans are also biased, and so there's a big study that came out showing that even humans were really bad at transcribing African American vernacular speech correctly. So it turns out that like things aren't great on all fronts, right? So we need to do better across the board. And so I think the main takeaway here is that actually we really should be working together with AI towards fairer outcomes. So combining kind of human expertise and allowing humans to review the output of speech-to-text systems is really going to be kind of the best path forward towards getting those fairer outcomes, not just in criminal justice, but in a lot of different domains as well. And so, is there progress? Question mark, question mark. The government has been involved in this. One big issue is YouTube captioning, and so are those captions actually correct because those are also automated? Can there be biases that would disproportionately harm deaf people, for example? Right, so that's something the government is interested in hearing about. There is a new law in New York City that requires that any time that algorithms are used in hiring, AI algorithms, the AI algorithms themselves need to be audited for bias. And so a huge part of AI hiring is actually now speech-to-text. So I don't know if y'all have done interviews with anyone in the recent past who have done these like recorded video interview screens that all uses speech-to-text. And so if your speech isn't being transcribed correctly, that could have a huge impact downstream on whether or not you're hired, right? So that being said, there's so much more to do, right? I've hit on maybe like 3 of these domains, but there's a ton more where fairness is a huge issue and really should be thought about a bit more. And so with that, my final pitch to you is keep hacking, but don't forget this whole space when you're thinking about tech, right? And with that, I will end. Feel free to email me questions. And also, this is a website where you can play around a bit more with the specific audio clips that I played. You can click on all the dots in the scatter plot and hear more audio samples if that's something of interest to you. And with that, I think we have like 10 more minutes, 5 more minutes. So I'll take questions from the Slido or in the room.
One question from Slido. Does board error rate correspond to misinterpretation? For example, are all word error rates the same?
So not all word error rates are the same. In fact, there's also this question of like, is word error rate even the right metric to use? Because maybe even if you mistranscribe a specific word, you can still kind of understand what the speaker was saying, whereas some words are a lot more important to transcribe correctly than other words. This is kind of the standard metric that folks use to measure things. So all of the companies will be comparing their word error rate metrics. But it's really important to keep in mind not just word error rate, but also the constituent parts. So are there a lot more substitutions or deletions? And also this overall kind of paraphrase word error rate is what it's called, for whether or not someone can actually understand correctly what the transcription is giving you. But the paraphrase word error rate involves a lot more humans in the loop, because you need a human to understand if it's paraphrased correctly. So it costs a lot more money, so very few people do it. Short answer, happy to talk more about that later, if helpful.
I think we move to the audience questions now.
Sounds good. Yeah.
The metric that you showed, like the percentage that was there, was it like the combination of the average WER performance?
Yep.
Okay.
It was the average across all of the snippets that we tested.
Okay.
Great question.
I know that you mentioned like the need for like better data sets. Do you think that's necessarily on like the responsibility of like bigger corporations or like the research labs or like what? Like who do you think should be building the data sets?
That's a great question. So currently all of the big public data sets are generally built in academia because it's usually research labs who are doing this careful lab work and then making it public. Private company data often stays private for obvious reasons, right? And so a lot of the bigger companies are now, as a result partially of this study, investing a lot more in this data collection step. But A, it's really, really expensive and time consuming to do right. And B, they don't have an incentive to publicly release these things. And so often, not that much data is kind of getting shown to the world. So privately, people are doing more data collection, but it makes it really, really hard for smaller companies to enter this particular market because they really just need a lot of money up front in order to pay people so that they can record their speech data. Does that make sense?
Mm-hmm.
Yep.
So, I guess really I'm sorry, like, where do you see this like being applied? So we have this understanding now of like how inequitable and like disparate like results can be when we use traditional technology for ASR. So where do you see this being applied? Like, would it be taken to court settings? To, like, you know, how would this be manifested? Like, what results would we expect to have as like this research?
Great question. So one big example, and this was the last thing I talked about, was this idea of auditing the AI algorithms used for hiring, and I see that being a next step for a lot of different domains as well. So not just hiring, but potentially also in court systems. Maybe you need multiple people transcribing, and then you have to cross-check against each other. Things like that sort of regulation are starting to be much more discussed in the public dialogue, especially with the EU coming out with AI laws. The US is thinking about this as well, right? So a lot of it is going to be in the regulation aspect of it. That being said, a lot of it is also on the company side of things, right? So a lot of these companies, now that they're more aware of these sorts of issues, are in fact investing a lot more in collecting data and auditing these models. One side note I'll mention is that this isn't entirely solved by data, right? And so one kind of easy example to point to is the fact that, actually, I don't know if you noticed, men do much worse in ASR technology, right? So women all had much lower word error rates relative to men. And this isn't because there are no men in the training sets, right? Like, in fact, the majority of the training data on speech is for men. This actually is because men tend to, on average, speak with more disfluencies. And so this means saying things like or talking at relatively irregular cadences on average, right? And so you can throw more data at the problem, but the acoustic models specifically aren't good enough at figuring out how to transcribe speech that is a bit more irregular of a cadence. And so that's what leads to kind of issues like that. So I think a lot more needs to be done, not just on the data side, but also on the modeling side. Yeah.
So you talk like how it's like not a data problem,
It's partially data.
Well, in a partially data problem, like I assume like if you throw like more data, more representative data, particularly for AAV speakers, that it would improve the model in some sense. But at the same time, I think like it's an interesting question in terms of like the model accuracy for different speakers in a sense. Like a model for English is not going to do so well if someone's speaking Italian. But even though AAV, I'm not going to compare like AAV as just English for English, but so I'm wondering like what you think about like presumably it could like worsen the model for some speakers by throwing different data. Where does like the equitable model fit, or should we not like look at it as like a one size fits all kind of thing and look to build technologies that adjust based on different aspects of speech?
This is a fantastic question. So kind of two different answers for this. First one is we actually never see this happen in practice. So if you make the training data more equitable, you add more data, you actually never see significant decreases in performance for other demographics of speakers. Broadly, this is because of transfer learning as like a general catch-all term to describe what's happening. Basically, if you have more data, you're going to help everyone improve. So in practice, we never see this happen. In theory, if it were to happen, this is something that you could always just solve by doing a classifier step before doing all the transcription. So like, if it seems like you're speaking quote-unquote standard American English, then you take your original model. If you are speaking African American vernacular English, you take this new model that's trained on much more AV data, right? So this is a step that you could do. In practice, no one does this additional classification step. A, because we never in practice see this issue, so C, previous point, and B, because it makes the transcription time a lot longer, so users are gonna have to wait a lot more because it takes time to classify and then transcribe. So yeah, does that answer your question?
Yeah.
Great.
I have a question. So you said because of like how inaccurate like the bigger tech companies like models were, and they were selling them to like for policing, that after that they did not sell them. So I hear like when people say like just the act of implementing these practices are violations of like, privacy, and just like putting more tech on a solution that isn't necessarily could be solved by more tech. But is like things like that trying to be advanced because it's not have you seen that it's not become a realistic expectation to dial back on the usage of tech?
It's a great question. And so I think this is a place where it's really useful to have ethics people in the room as well, and philosophers, and broadly people plugged into all sorts of interdisciplinary places. Because looking at it from just the like traditional CS lines is like, oh yes, this clearly will help some people, and so therefore we should like make it as good as possible. There's also a bunch of counter arguments to that, so not just kind of at the bigger level that you're talking about, but even at the stage of like, oh yes, we should collect more app speaker data because it will make the model better. Like, do we have enough app speakers who would actually consent to that? Do app speakers want to be reported, right? There are all sorts of tricky ethical issues to think about on each of these individual steps. Overall, my impression is that speech to text can do a lot more help than harm if they're regulated, right? So like these are things that especially individuals with disabilities need in order to, work in society, for example, or be educated via, say, video captioning for Zoom lectures and things like that. This is in fact also something that is already regulated by nature of the Americans with Disabilities Acts. And so kind of speech to text is already a place where we know we need to have it in society in order to have folks with disabilities be able to interact with these online tools. And so given that constraint where it is helping people, how do we make sure that it really only helps and doesn't hurt subpopulations of those groups? But I think these are great questions to raise at any point.
So I could really relate to a lot of your talk because I have myself worked on ASR system for like 23 Indic languages. And one of the things that we noticed in terms of language model that we were using and in regard to the WER was that if we feed in, like for example, if we wanted to go for a financial domain and if we feed in more of the financial words to the language model that we were using for that transcription, it kind of increased the decreased the WER for about 5 to 10% as well.
Yep.
So I wanted to take your note on that for specific domains where we want to use, for example, like criminal justice or education, do you think that changing the language model and just keeping the rest of the thing generalized would kind of solve the problem instead of, maybe not just have like a racial bias, but it's like more of a language
Jargon
model
wise,
Yeah, yeah.
Great question. So first answer is actually a lot of companies now, because part of my response is like, you have these big tech companies, it's like impossible to compete with them on kind of a overall thing. So a lot of smaller companies that specify certain niches, and so there are actually specific speech-to-text companies that say, hey, we do really well on business and financial tech things, like they're trained entirely on like earnings calls, like that's their thing, and they do really well on that specific domain. And so oftentimes for these sorts of niches, there are specific products that people have already made, and they're great for those specific niches. That being said, one kind of way that these more general models are kind of encroaching in that space is with the fact that you can actually specify certain lists of lexicon or jargon. And so if you say like, oh, I don't this earnings call, I'm going to be talking about the ticker goog a lot, and so like I'm going to input that in the lexicon, and that means that they'll correctly transcribe it for what I want to hear. So that's one way that you can kind of work around it, and in some ways, one could say that's fine-tuning the model. You don't actually have to do any of the work, right? Like it's all just a nice UI that you can use, but that's one way to get around it. And a big thing that's happening now is with the advent of LLMs and ChatGPT-esque technology, this is becoming much easier to do, especially in the speech-to-text, right? So like I mentioned, LLMs are a part of speech-to-text models, and as such, there is a lot of generative AI that's being used, and you can actually input this specific list of keywords or like domains that you think will be present in the speech that you're trying to describe directly in, for example, the OpenAI Whisper query. So as you're transcribing, you can define different words that you expect to see. And so generative AI does really well for it, but also massive harms in that it also hallucinates a lot, right? So like you have all sorts of issues here. All right. Any other questions? Great, this is perfect timing to get back on track. So with that, thank you so much. Really appreciate your time.